BPF has been around for years and years and years. Things like setcomp filtering use BPF. The thing that's happened is as BPF and eBPF has evolved in the kernel, new features have been added, new capabilities, new places that we can hook into. This is happening inside the Linux kernel, and it takes quite a long time for a new Linux kernel to make its way into the distributions that people are actually using in production. We finally crossed a watershed now where most people's production kernels have pretty decent eBPF capabilities.
Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source, containers, and infrastructure as code. To learn more, visit snyk.io/TSD. That's SNYK.io/TSD. On today's episode, Guy Podjarny, founder of Snyk, talks to Liz Rice, Chief Open Source Officer with eBPF pioneers Isovalent. At Isovalent, she works on the Cilium project, which provides cloud-native networking, observability, and security. Prior to this role, she was the VP of Open Source Engineering with security specialist Aqua Security. She is the chair of the CNCF Technical Oversight Committee, co-chaired the KubeCon and Cloud Native Con 2018 events in Copenhagen, Shanghai, and Seattle, and is an ambassador for Open UK. She is also the author of the O'Reilly book, Container Security. Liz has a background in system software engineering and loves writing code and helping other people understand complex technologies. We hope you enjoyed their conversation, and don't forget to leave us a review on iTunes if you enjoyed today's episode.
Hello, everyone. Thanks for tuning back into The Secure Developer. Today, we have a great guest that I've actually sort of been waiting to have on the show for a while now. And we have a million things we could talk about, but we're going to talk about two primary ones, which are eBPF and CNCF and its role in security. And to talk about those, I'd like to welcome Liz Rice, who is the Chief Open Source Officer at Isovalent, as well as the Chair of the Technical Oversight Committee at the CNCF. Liz, thanks for coming onto the show.
Oh, thanks for inviting me. It's my pleasure.
So Liz, before we dig in to the sort of the meaty topics we have ahead of us, can you tell us a little bit about what is it that you do and a bit about the journey that got you here into security? You're sort of worked on security more directly maybe before than now, but tell us a bit about the journey.
Yeah, so I've been in software, forever and ever. And I guess maybe about 5 or 6 years ago, I was working on a startup that was basically failing. And while that was failing, some friends of mine were saying, hey, this containers thing is looking really interesting. Have you come across Docker? And they persuaded me to start a new startup where we were looking at container scaling technology. And that startup also didn't go very well financially, but I did learn an awful lot about how containers work and kind of got involved with the community and met a ton of really great people. And I knew that I wanted to stay in the containers space. And from there, I joined Aqua Security. And that's really where I got more involved in the security side of containers. And I really approached that with the mindset of a curious engineer, which is what I am at heart. I wanted to understand how containers work and how an attacker could go about compromising a container. So I really wanted to get into the details of that. I ended up writing a book, the Container Security book. I guess after 4 very fun years at Aqua, I then moved into more the eBPF space. So eBPF is a technology, we'll talk about this more shortly, I'm sure, but it's something that had really caught my eye a couple of years ago. And the opportunity to join Isovalent came along. And I thought, yeah, these people really know this eBPF space. So now, eBPF has got some interesting capabilities with regard to security. So I wouldn't say that I'm not at all in the security space, but it's not 100% of what I'm doing now.
Yeah, no, understood.
Yeah.
And Liz, how sometimes security is this daunting thing when you're not in it, and before you get into the industry. I guess how did you find getting into sort of a security focused surrounding? When you got into Aqua, did it feel like a very steep learning curve over there? Was it scary? Was it actually not so much?
Yeah, I think security does look pretty daunting from the outside, and there's lots and lots of acronyms and lots of jargon and terminology. And the way I approached it was really, I don't particularly care about the acronyms. I'm much more interested in understanding what's really going on underneath. How did this attack work, or how is this attack surface vulnerable? And I really enjoy kind of digging into those things and really getting into like how these things work. So my approach was really to be a bit, I suppose, a combination of naive and sort of just determined to get to the bottom of this. So I tend to kind of, when people use a jargony term, I'll just ask what that is. So I don't know what your 3-letter acronym means. I want to understand what that means. And I think it's actually not so difficult when you kind of get to the fundamentals. You just have to sort of scrape off this veneer of what all these acronyms mean. And there's plenty of complexity there, but there's plenty of complexity in engineering in general. So I would say anybody who's interested in software, there can be some really interesting security. It's like problem solving. That's why we're all in this kind of engineering space in the first place. We want to kind of understand how these things fit together and how we could change them and how we could solve problems with them. So security feels to me a bit like a very problem-solving angle of software engineering.
Very cool. I mean, that's that's kind of my sentiment as well on it. And did you find, I guess on the flip side of it, you came with this sort of rich understanding of DevOps and kind of cloud and container technologies coming into it? Is that I guess when you got into the sort of the industry after all, right? Sort of talking to other people in the security space, I guess what was your sense of familiarity with those worlds? Was it a high hurdle to get people familiar with them? Is there actually kind of a lot of openness and interest in learning them on? I guess you were in container security, so there must have been some amount of selection bias, but was it hard to teach the other way around? Kind of, teach that audience about containers and DevOps?
I think the biggest challenge, and I still see it today, is just people having maybe not quite the right mental model around what containers are. And containers are essentially just processes. They're not really, especially from the Linux kernel's perspective, they're not any different from a normal process. But sometimes people come with this idea that because they kind of look and feel a bit like a virtual machine, maybe they are a virtual machine, and they're not. They're much, much closer to just being regular processes. So I feel like a big part of the education that I've been trying to provide over the last few years is explaining to people why they should think of it more as a process on a shared machine. It's got a common kernel, what the implications of that are, just really fundamental things like, if you're root inside a container, probably root on the host as well, unless you're running with user namespaces, which most of us aren't today. So that's the same root. You don't be relying on that root being different in a container. That's going to get you into trouble potentially.
Yeah, it's very
so
convenient.
That kind of misconception, I would say, is the sort of thing that I like to try and clarify for people.
Got it. Yeah. Well, it's always easier to sort of relate it to an existing mental model, I guess, when you digest those. So I guess, this is containers. I think most listeners are sort of familiar enough with them, whether they think of them as a VM or as a process. Let's talk about this sort of cutting edge tech world that you live in today. Tell us a little bit about eBPF. For starters, like a bit of a primer, like what is eBPF?
Yeah, so it stands for Extended Berkeley Packet Filter. And I usually say that's really not terribly helpful. It comes from a background in filtering network packets and attaching kind of custom code to decide what to do with those packets. But now it's been extended to basically any part of the kernel. So you're not just filtering packets, you're also able to hook into any function call, entry or exit, or a trace point, or a number of other different points across the whole Linux system. and run custom code to decide what to do, or maybe to extract data for observability purposes. And because we can hook into anywhere in the Linux machine, but most typically within the kernel, and because the kernel is shared across a whole virtual machine, so all of your containers running on that virtual machine have this kernel in common. So that means we can use eBPF hooks to see what's happening in all of our processes, whether they're containerized or not. And it gives us this really powerful mechanism for observability and for security, as well as networking, if we get back to the kind of packet filtering side of things. And yeah, so it's also very performant because we can run in the kernel. And it's opening up a whole new world of things, of ways to implement networking and security and observability tooling at runtime.
Yeah. What happened to, like, eBPF has been getting attention recently? Is it that it's new tech? Is it old tech that's been rediscovered? I mean, what kind of brought about its renaissance?
So BPF has been around for years and years and years. Things like setcomp filtering use BPF. The thing that's happened is, as BPF and eBPF has evolved in the kernel, new features have been added, new capabilities, new places that we can hook into. This is happening inside the Linux kernel, and it takes quite a long time for a new Linux kernel to make its way into the distributions that people are actually using in production. We've finally crossed a watershed now where most people's production kernels have pretty decent eBPF capabilities. This wasn't true, a couple of years ago. Almost nobody could run, well, that's a little bit of an exaggeration, but a lot of people couldn't run eBPF tooling because they just weren't running up-to-date enough kernels. But now most people are, so that's why we're seeing this explosion of interest in eBPF tooling.
Got it. So it's now applicable. You can actually sort of rely on its presence, on your ability to
Yeah. You're not going to find that you try and install something and it just says, no, sorry, it's not supported on your machine.
Yeah. And so before we dig into kind of a practicality of what you can do with it, who's you in this context? I mean, if you're running eBPF, like, what type of hat are you likely running? Are you an infrastructure engineer, an application developer? Who typically deals with choosing to install eBPF or with writing code that runs in it?
So in terms of who's going to be installing eBPF tooling and eBPF programs, it's most likely to be infrastructure teams, platform teams, essentially people who you would allow to have root access or the ability to reinstall a whole machine, because we are talking here about changing what's running in your kernel. So absolutely, you don't want, anybody, probably not even any application developer, just sort of changing what's happening in your production cluster at a kernel level. So yeah, in terms of installing, choosing tools, most often it's going to be a platform team. The results of those tools, the kind of observability that we're able to offer, for example, could very well be applicable to the application developers. So I think we're quite likely to see that information being shared more and more with developers, and particularly as we see more tooling being developed and making these eBPF programs are quite often running in quite a sort of esoteric kernel context with lots of kind of kernel related data.
Talk about acronyms.
Often, it needs to be kind of
world.
Turned into something that's meaningful for application developers most often.
So I guess maybe let's dig into indeed those bits of functionality. So what, for example, can eBPF do, and maybe like which tools or functionality would it replace? What can you run on it?
So some of these tools, a lot of people will have come across, particularly at the command line. If we go back to, there's a framework called BCC, which a lot of tools have been written in. And there's a lovely diagram that illustrates the kind of scope of, it's basically a picture of a Linux machine, and it's got boxes for networking, and inside that there's TCP and IP and sockets and network packets, and there's a similar box for storage, there's similar box for user space, there's memory management, all these different parts of a Linux operating system. And then there are all the tools that have been written in this BCC framework to allow you to get observability data from these things. So things like TCP dump, that's a tool that a lot of people will have used to take a look at network traffic, and that's using eBPF to hook into TCP IP stack and provide information that we can, find very useful for seeing what network traffic's flowing and potentially debugging network issues. So those kind of command line tools, a lot of them are actually, available. You can install them and, use them on the command line, and have been able to for a while. We're now also seeing more cloud native implementations. Another example would be, it's a tool called Inspector Gadget, which takes those BCC tools and hooks them into the world of Kubernetes. So you can say, run TCP dump, but in the context of this particular Kubernetes pod or service. And then, of course, there's Cilium, which originates at Isovalent, and Cilium's using eBPF to provide Kubernetes networking. And an example of how we're using eBPF technology there would be for network policies. So Cilium's connecting all the different Kubernetes endpoints, all the pods, all the IP addresses that are associated with these different endpoints. So it knows which IP addresses are associated with these different Kubernetes identities. And then we can look at each packet and see whether or not it passes any network policy very, very efficiently, because we can drop those packets very quickly in the kernel if they don't meet network policy. And then we can also provide information of some Kubernetes aware network flow. So if you look at TCP dump, it's all in the context of IP addresses and ports, but using something like Cilium, we can associate that with the Kubernetes identity information.
And do routing or sort of make decisions based on Kubernetes primitives.
Exactly. Yeah.
Is it fair to think about this, not to reduce it again to, you were saying, network is just a piece of it, but is it fair to think of it as sort of a kernel level network router, sort of a network switch? Like a lot of the functionality you're describing is really something that historically would be in some sort of switch or router that sort of sits in your network.
Yeah, absolutely. I think that is a good way of thinking about it. And if we think about the context of container networking, I find this pretty interesting. In a virtual machine, you've got, in a Kubernetes host, you've typically got one networking namespace per pod, and you've also got a networking namespace on the host. And each of those networking namespaces is running its own stack. And what that means is, in a traditional sort of non-eBPF networking environment, a packet arrives from the outside world for one of your pods, and it has to go all the way through the networking stack on the host to then get passed through the virtual Ethernet connection into the networking stack in a pod to reach the container that it's destined for. But it always had an IP address. It always had its destination IP address. And what we can do with eBPF is we can look at that packet the moment it arrives at the host. So before it's gone through the host networking stack, we can see it's destined for a pod, essentially to a container on this machine. So we can just send it straight there, and we can completely bypass the host's networking stack. And it's still going through networking on the kernel, because the containers stack is also using kernel primitives, but we're bypassing a whole chunk of it.
Yeah,
and that's one of the reasons why it can be really efficient.
Yeah, I think back maybe to your comment before about to an extent you're sort of turning that container into being something that's a little bit more of a virtual machine in that context, kind of moving it back.
Yeah, I guess you could look at it that way. And the other thing that's really interesting, and I think the future of this, is for service mesh, because again, we've got this awareness of Kubernetes services. So we can still use things like Envoy to do kind of layer 7 inspection, but we can be much more efficient about this. We don't need to have the sidecar model.
Yeah.
Because sidecars are used because you typically need to be in the same namespace as the pods that you want to observe or instrument with a sidecar. If we use eBPF for this instrumentation, we don't have to have one sidecar per pod, because in the kernel, we're aware of everything anyway. So using that Envoy as an example, we can just have one instance per host, which is a lot more efficient.
Yeah. And this is just to sort of call out what I think are the limitations. Like, that does require running an operating system, right? If you're running Lambda or a serverless platform, can you still run eBPF? Like, it's not your machine at that point.
Yeah, so you wouldn't have access typically to running eBPF functionality in that kernel. I don't know whether, if we look into our crystal ball, we might see a future where people will be allowed to attach particular, it would make sense to me to say, even though we can, if I'm a cloud operator, I might say, well, I'm controlling the kernel and I'm going to be very specific about what I allow you to do, but maybe I'm going to allow you to turn on certain eBPF functionality or load certain eBPF programs.
Right. Yeah. Or implement maybe some of general capabilities through sort of eBPF themselves. Yeah. So I think, eBPF sounds somewhat all-powerful, but everything we talked about until now were really around networking capabilities and around maybe more performance or usability around those kind of Kubernetes primitives. When you think about security, what are some examples of what you can do where eBPF can benefit security?
So I mentioned network policy. That's one angle of kind of runtime security enforcement. Another area that's pretty interesting is executable and file access security. So some of the things that we might traditionally do with AppArmor or SE Linux, controlling which processes can access which files, for example. Pretty complicated to set up those profiles. AppArmor and SE Linux weren't originally designed for a container environment, so it all gets quite complex. But if we're in a microservices environment, typically our software is doing, that microservice is doing a pretty limited set of things. It's only expected to access a certain set of files or run a certain set of executables. Quite often, the timing of running those executables, if you're running a microservice, you might have some initialization and then pretty quickly it's running one thing. If a couple of hours later it suddenly started running something new, maybe that's a sign of compromise. Maybe we look at what that executable is and it turns out to be a cryptocurrency miner or something. This would be bad, right?
Yeah.
So we can pretty easily think and build a mental model of what we expect our services to do in terms of file access and network access and executables. And eBPF gives us this ability to see that file access. We can hook into reading and writing files. We can hook into network connections. We can hook into running executables. And we can start to use eBPF to police that. There are tools today like Falco and Tracy from my former colleagues at Aqua that will look at the executables that are running and match that against the known profiles. There is more work going on in the eBPF world to not just kind of observe that these potentially malicious things are happening, but also to be able to put controls in to say, no, you can't run anything, an executable unless it matches a set of
certain policy.
A policy.
So I guess kind of graduating from network policy to execution policy or sort of other kernel commands.
Absolutely. Yeah. And just really restricting what each of those microservices is allowed to do, in quite a powerful shrink-wrapped way.
Yeah. One of the things I find interesting around eBPF is trying to kind of wrap my head around is this user space or is this sort of a platform space? Is it So, I mean, writing, for starters, you mentioned there's the permissions element of it. You wouldn't want just anybody modifying eBPF on your system, if nothing else, because it runs on the entire system and all the containers that run on it. And also similarly, like it's not easy to write eBPF, right? I mean, it sounds like pretty hairy, low-level code you need to create, right?
It is. It is a bit of a sort of specialist endeavor, and it's quite fun, fun in the engineering sense, because, or one aspect that makes it quite, quotes, fun, verification. So when you're running code in the kernel, it's very important that it doesn't crash or get into an infinite loop. So there's a verification step that happens before any eBPF program is loaded. The kernel will verify, and what that verification step is doing is looking for loops, and it's looking for memory access, making sure that all the memory access is safe and as expected. And that means you have to, for example, every time you dereference a pointer, you have to explicitly check that it's not nil. If you don't have a check for nil pointers, then your verification step won't pass and you won't be allowed to load that program. So the verifier helps make sure that these BPF programs are safe to run and that they're not accessing memory outside of the scope of what they're supposed to. But it can be a bit of, there's a nice quote from NCC Group. It's something about the verifier being a fickle beast or something like that. It certainly can require a little bit of, sometimes just moving a line of code somewhere just reordering it can persuade the verifier that it's safe, even though it looks to my brain sort of exactly the same. So that can be a little bit of fun. And you also can quite quickly end up needing to understand the kernel context. So you're running this custom code that you're writing in the context of something that happened typically in the kernel. So you might have a kernel socket buffer to look at, and you're going to have to know what that socket buffer, how it's structured. That you pretty quickly getting into some nuts and bolts there, some pretty detailed nuts and bolts. So I don't expect many people, most application developers are not going to also be writing eBPF code. They're going to be using eBPF tooling, but I don't think they're necessarily going to want to. I mean, it's fun. I don't want to put anybody off if they're interested in that level of, getting into the weeds there.
Touches that sort of engineering bone over there. But I think so. I think that's an important, I guess, kind of aspect to grok here, which is, eBPF sounds super powerful. I think for most of us, it wouldn't be because, we're going to find ourselves replacing JavaScript for eBPF. That's not, right. The sort of the right trade-off or to think of it.
Yeah,
or
exactly.
Even, I guess Go, maybe you're sort of starting in Go, Rust, you're kind of getting a little bit closer, but still it's even lower level than that and even more involved. But I guess it's an important capability to help all of us understand the art of the possible. It might imply things, would be some order of magnitude faster or closer, or where is it that you can apply? So it is kind of like sidecar. I guess is that maybe that's the best way to think about it. Is eBPF is sort of unlocks possibilities like sidecar unlocked possibilities, because suddenly you can install tools in this fashion, you can apply rules and apply capabilities in this fashion. So just like sidecar has become, it's gone from something that none of us ever knew. Maybe a few more people are writing sidecars than eBPF, but it unlocked possibilities. eBPF is doing something similar.
Yeah. We can certainly think of it as a similar way of stepping up the level of, I guess, what we can see. We had that sidecar model to allow us to inspect what's happening inside a pod, and I guess eBPF allows us to say, actually, let's take that, we're going to step it up a level and see everything across the whole virtual machine.
Yeah, no, for sure. And it's interesting a little bit to sort of see the tensions maybe between, on one hand, a desire for some to move to more of a serverless surrounding, kind of, try to forget their servers under there and move away, versus maybe the opportunity with eBPF, which is sometimes, well, if you remember there's a server under all of these containers, you can actually do some fancy stuff.
Exactly. And as an end user, you may be completely, happily oblivious to what's happening on those servers. But somebody's got to manage those servers, and somebody has to, keep those servers safe. And maybe they're using eBPF, even if it's not made accessible to you as the serverless user.
Yeah, absolutely. So I think eBPF is fascinating. Thanks for kind of giving us here sort of a bit of an overview of how to sort of think about it. What are the capabilities? People definitely should sort of check out Cilium and I guess Isovalent as the commercial backer there. I want to sort of use the time, there's so much to talk about. Use some of the time over here as well to sort of switch to a very different topic, a very different hat that you are wearing. So you are also, as mentioned at the start, you're the chair of the Technical Oversight Committee at the CNCF. I'd like to think that most listeners are sort of familiar with the CNCF, but do you mind giving us a couple of words about, CNCF and what is the Technical Oversight Committee?
Sure. Yeah. So CNCF stands for Cloud Native Computing Foundation. It's part of the Linux Foundation, and it's the entity that owns the intellectual property and provides a home for projects like Kubernetes and Envoy and Linkerd, and there are just dozens and dozens of projects now that are all in the realm of cloud native. And
it's the biggest foundation, I think, within the Linux foundations.
It is, sort of yes, and I think it's something like the fastest growing foundation of any open source foundation, I believe. Certainly, hundreds of thousands of contributors, across the projects. And as the Technical Oversight Committee, we're there to set or perhaps also enforce the technical direction of the foundation. So kind of what do we mean by cloud native? And if a project wants to become part of the foundation, is it cloud native? Does it to meet those attributes? We have a pretty light touch as a foundation, so we don't require any particular governance model. We don't dictate what those governance models have to be, but we do want to see open governance in every project. So we do exercise a level of kind of policing around making sure that projects are well run. And with the TOC, we're responsible for assessing whether new projects should join the foundation. And we also look at the level of maturity, whether they're experimental and should really be in the sandbox, through to graduated projects where we're saying, yeah, that's a well-run, well-established project with lots of adoption. And as an enterprise, we think you're not taking any significant risks to use those projects. So things like Kubernetes and Prometheus and Envoy and several others fit into that category. Yeah. And in between, we have incubation, where they're being used by at least some people in production. Potentially, there are some things we would like to see improved about governance model. We want to see a bit more track record of collaboration, but they're nonetheless pretty well-established projects at incubation level.
Right. And collaboration, you're sort of implying you don't want sort of a single commercial party to be kind of dominating, any of these projects, because they're meant to be an industry collaboration. Is that what you're referring to?
Yeah, that's right. I mean, I think it's important that the CNCF, it's part of a community, and that community has everybody from individual contributors up to giant, the big cloud providers, and in between lots of independent software vendors as well. And we want it to be an environment that allows everyone to be successful. But I think that does mean, that the CNCF isn't there just to give a vendor's project a leg up in marketing. It has to be a truly community-oriented project. And we prefer to see multiple collaborating entities, whether they're vendors or end users. We like to see lots of organizations being involved in a project.
Yeah, makes perfect sense. So I think from a security lens, the CNCF and maybe specifically the Technical Oversight Committee have a bit of a dual role, right? Like there's an aspect of how do you help CNCF projects be secure, And there's maybe the question about CNCF's role in helping all of us build secure applications on top of sort of CNCF or secure platforms. How do you help people use CNCF's products securely, right? Is that correct? And maybe I'm over interpreting things. How do you think about security in the context of the committee?
It's definitely something that I wouldn't say is completely, it's not finished. There's more that we can do in the world of security. For the TOC, there are 11 people on the TOC, but we're a much bigger community than that. We have a set of technical advisory groups that we kind of rely on and outsource for their expertise. One of those tags is security. So that is actually, I think, the most active of all the tags. So if there are people listening and interested in getting involved in the CNCF's security work, definitely reach out to the security tag. There are some amazing people and some really good projects that you can get involved with. They'll do things like provide a security buddy for a project that, a lot of projects don't necessarily have security expertise on board already, but the security tag can help match them up with someone who can take a look at maybe some of the security aspects of a project. So that's a relatively new capability that the communities can pull together to offer to projects to help them be more secure.
And this is the primary objective over here is for help the projects themselves to be secure, like minimize and then address if they happen vulnerabilities in the project, secure access to the code, et cetera, right? As opposed to their security capabilities necessarily that they
exactly. Some projects have nothing particularly security related about them, but but
all of them should be secure.
Exactly. And also encouraging things like a responsible security reporting process. That's something that we've added into the graduation criteria relatively recently, and something we've become conscious that, actually projects do need to have that route for people to report potential security issues. And also the CNCF for graduating projects provides security assessments that are done by a third party, full kind of pen testing assessments. So that's another, service that the CNCF is offering to the user community. You can look at the assessments that have been done on those graduated projects. I think that, not all of them have been done yet. It's a work in progress, but it's a pretty significant investment.
Yeah. And it's, to an extent, and I know, security isn't the specific focus of the talk, but it's a sort of massive volume of developers. You mentioned before, over 100,000 contributors. These are all developers. They're building systems that in turn are massively prevalent, oftentimes by definition of being a part of this foundation. And yet you're nobody's boss in this context. Like there is nobody that's sort of telling anybody what to do. I guess what's your sense of how that's working out? It's to an extent the very essence of empowered developers, building those out, but also, boy, is it a high impact surrounding if you slip up. I guess how do you manage that, right? Or how does the CNCF manage that?
Yeah, I think it's incredible how these hundreds of thousands of people have been able to pretty much self-organize in a pretty successful way to, develop in all these different projects. And I think that self-organization didn't come from nowhere. It came from some really intentional thinking by people in the early days of the CNCF and in the early days of Kubernetes, thinking about how contributions should be sort of managed and contributors should be onboarded. So I'm thinking about people like Sarah Novotny and Paris Pittman and the people involved today in the contributor strategy tag that's part of the CNCF. People thinking about how these groups of essentially volunteers can manage and what's the sort of best practice ways of providing ways for people to grow in those roles and go from their very first contributions through to leadership roles in open source. And it didn't happen by accident. It happened because people put some really careful thinking into it. So I'm thoroughly grateful for that.
Yeah, no, I mean, I think in my mind, another probably a dedicated podcast topic on its own there. So we'll dig into that. One more question on CNCF before the closing one here, because I think we're going pretty long. There's so many things to I guess as anticipated. So how do you think the CNCF is building the foundation, or much of the foundation, for cloud native computing? Indeed, historically, it's been much more ops oriented, sort of DevOps oriented, than necessarily app dev. There have been some works on sort of application and working groups and things like that. When you think about the CNCF and where it's progressing towards, do you think more projects there would be app dev oriented? Do you think the CNCF's role is really still kind of in the infrastructure layer and the DevOps layer? How do you see that?
No, I do think that application development and delivery aspect is very important. And we see projects like Backstage that came from Spotify, which is a developer platform. I think we will see a lot of other projects, and there are several other projects in that area, whether it's about how applications are built, things like build packs, how developers interact with that platform, the whole world of GitOps, and how development code gets into production, and how that sort of pathways management. I think these are all areas where we will see more projects, some consolidation. I think in much the same way that we standardized on Kubernetes, and we have a pretty good common understanding across industry on how we manage Kubernetes clusters, I think we might start seeing more standardized ways of how we deliver application code onto those clusters. Yeah.
I think that sort of is consistent with what I'm seeing here, and I think we'll be building a lot more. So Liz, thanks for this sort of view into maybe the foundations on top of which we're building. I think like eBPF from an exciting new evolution, and what we can do with it. The CNCF is maybe where a lot of that gets coordinated and packaged up for us to consume. Before I let you go, one last question I'd like to ask all guests coming on the show. If you take out your crystal ball and you think about someone in your shoes 5 years from now, I don't know which shoes those are. Maybe you're indeed sort of orchestrating. You have a lot of things going, but thinking about maybe this reality from an industry leadership, from whether it's the open source activities or the open standards. What do you think in 5 years would be most different about your reality?
5 years is such a long time, isn't it, in this space? 5 years ago, Kubernetes was barely, it was just a new thing, and we didn't know.
Like eBPF was.
yeah, absolutely. So setting aside whether or not we'll have, the climate apocalypse in that time frame, let's hope that doesn't happen. I mean, we're seeing such rapid adoption of cloud technologies. I think it will be table stakes for any company to be just using the cloud. We won't be talking about early adopters anymore, for sure. So difficult to say. I'm sure we will see huge advances in observability. We'll see massive scale. We'll see the proliferation of things like edge and the Internet of Things. So many more entities that we'll need to sort of monitor and secure and control. So I think that will add a whole new layer of, we think things are pretty massive scale already, and I think that's only going to explode over the next few years. So we'll all have our work cut out for us building the tools that will manage that and secure that and allow us to keep an eye on what's happening. Yeah.
You're sort of seeing it getting messier before it gets cleaner, I guess, in the evolution. More and more moving parts.
Yeah, I mean, everything's always a bit of an arms race, isn't it? Things get worse, and then people build a solution, and then things get worse, and people build a solution. And I suspect that will be true with the scale of, internet connected devices.
Indeed. Liz, thanks for coming on the show. This was a great conversation. I do fully believe we probably could have spoken for another hour and still kind of scratch a lot of things. But thanks for coming on and sharing more knowledge and views with us.
Absolutely a pleasure. Thanks for having me.
And thanks everybody for tuning in. And I hope you join us for the next one.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecCon. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.